what will be the frequency linear for a simple pendulum? 1 over 2 pi G over L. And what will be the period for a simple pendulum? This said also that these three parameters are independent of the amplitude. What will be the amplitude here? I can put this either. If I use this equation, I can use the amplitude as the angle. Why? Because S, I can put it as L, the second derivative of the angle, using the angular acceleration. Remember that L, angular acceleration L, or R, times alpha is A. If I put it like this, I can put negative G theta. I move L to the side and will be the same thing. Except that now what I call amplitude here for the pendulum, instead of distance or R length, which is not very well seen, I can use as amplitude the angle for a simple pendulum. So what will be amplitude? Is the angle from the vertical, from here. This is what we call amplitude for a simple pendulum. We can use R length, but it's not very well seen. So it's better to find the angle, and that is the amplitude. So if I have a certain amplitude, you can see that no matter what, if I do from here, or from here, or from here, the period will be the same. So you can see. So the period from here is the time to complete or to come back to here. But if I do from here, will be the same period. Or if I do from here, will be the same period. Why? Because the simple pendulum is independent. These three parameters are independent of the amplitude of the angle. On what depends though? On the length. So if I increase the length, if I just come here or shorten the length, what will happen to the period? The period will be shorter. So you can see that if I make this shorter, look at the period. So if I use this, the period will be shorter. If I increase the length, you can see that the period is longer. And also depends on the gravity. Depends if you are here or you are in the space. So in that case, the pendulum will change. Any question on that? Okay, this is what you need to know from the oscillatory perspective. This is what you need to know from the dynamics. And finally, energy. We already studied energy before. So what is the energy of the simple pendulum? When it's here, what will be the type of energy? Potential. And what was the formula? mgl 1 minus cosine theta. In this case, theta max. That's the energy here when the energy is completely potential, which is mgh. But h is L times 1 minus cosine theta. What will be the energy when it's at the bottom? Kinetic. And it's maximum kinetic. And what is the energy at any point? Between here and here, there is a middle point here. What type of energy will have? Both. So it will be 1/2 mv squared plus mgl 1 minus cosine theta. This is what you need to know about the simple pendulum. And finally, so here, let's get the study guide. See if we have question here where we have one question that I can reproduce different questions. So here we have spring, light spring, light spring. So in the first part I don't have any pendulum. in the second one, I have a physical pendulum. Yeah, I don't have any pendulum question here. Yeah, I don't have any pendulum. Okay. So, what will be the typical question here? Yeah, all the questions are with the spring. Yeah, all questions are with the spring. Let me transform question number 4. Question number 4. So imagine that question number 4 is a simple pendulum. Imagine it's not a simple pendulum. Say the figure shows a uniform rod suspended from a pivot a distance d, forget about. Let's say that is a pendulum that is suspended from the end, and the angular frequency, find the angular frequency for small oscillations. So we need to find, the figure shows the length of the pendulum. Imagine that this is a simple pendulum. The length is 1 meter. The mass is 2 kilograms. Suspended from a pivot point, which suspended from a certain point, forget about the distance and of the center of mass. So find the angular frequency. What do? If you want to find the angular frequency, it's a simple pendulum. Not a this is a physical pendulum, but I am changing. So you just use the formula to find this. Since I give the length, you can find